Hello everyone, my name is Pravesh and welcome back to my channel. In today's video, I'm going to show you how you can create a custom AWS CLI using Python and Boto3. Yes, you heard that right. We'll create a custom Python AWS CLI that will help us to manage operation related to EC2, S3 and Lambda, all directly from our terminal. So if you are a DevOps engineer or someone learning about cloud automation, this project will give you solid hands-on experience. But before that, I'm here to bust a common myth about DevOps engineer that DevOps engineer don't code. But the truth is, we do code. We write policy, automation script to ensure cloud operation went smoother and faster. And today's project is extensively focused on that. We'll automate common AWS actions using a Python CLI. So this will help you understand how Boto3 works under the hood and how AWS integrates with Python. Before we get started with the project, make sure you have AWS CLI installed, configured with an IAM user that have full access to EC2, S3, Lambda and IAM. And if you don't know how to do that, I have covered that in detail in one of my blog. I'll link it down in the description box for you to check it out. Last but not the least, we need to have Python installed on our system. So once we have that, we are good to go. So the code for this project is hosted on my GitHub repo, Python for DevOps. So this repository will contain all projects related to Python and DevOps tool. So currently it has only one project, which is automate EC2, S3 and Lambda. And this directory will contain the code of our project. So what I want you to do is fork this GitHub repo under your own GitHub account and give it a star so that you don't miss any update. So using git clone command, you can fork clone it under your own local system and open it inside VS Code. So I have already done that. So here are the files. So we'll go through it one by one. So firstly, we have this EC2 manager.py file. So firstly, we are just importing Boto3 module and its client error exception module. So we are defining a class, and here in the init block, we are defining that our Boto3 client will be EC2, and the region name will be US East 1. So in the first function, the create instance, we are defining some parameter, which is firstly the Boto3 client EC2, and we are having this default AMI ID, which is particularly for Ubuntu US East 1. If you have a different region, you need to change it. And the instance type will be T3 micro, and we are providing a key name null, so that if you want to give it, you can. So firstly, we are defining some parameter which include image ID, instance type, minimum and maximum count. If a key name is provided, we will add that in the parameters. And here is the main part. Using the Boto3 client EC2, we are running this, getting this function run instance and are defining our parameters. And if everything runs fine, we'll print our instance ID here. And if any error occurred, we'll print our error using this client error. Next, we have this list instance function. It will list all the EC2 instance. So firstly, we are getting all the EC2 instances inside this response variable and declaring an empty instance array. And using for loops, we are defining some parameter, which is instance ID, state, type, public IP. And if we found any, we'll append this empty instance array with it and return the array. And if any error occurred with it, we'll just list this error here. And at last, we have this terminate instance. So we are using terminate instance, and it takes an array of instances. So we are defining our instance ID from the function and then array. And if everything worked fine, we'll display this message. And if any error occurred, we'll display the error here. Similarly, in the s3 manager.py file, we are importing Boto3 and its client error module. We are defining our Boto3 client as S3, defining the region name. And our first function is create bucket. So it basically take one argument, which is bucket name. So we are using s3.createBucket and providing the bucket name. And if the bucket is created successfully, we'll print our message. And if any error occurred, the error will be printed here. The most probable error would be the name is already taken. And the next function is list all the bucket. So we'll use s3.listBucket, and it will generate us an array of buckets. So using for loop, we are just getting the name of it in the buckets JSON array, and we'll return this bucket. And if any error occurred, we'll list that error. And at last, we have this delete bucket function. So using s3.deleteBucket and providing the bucket name, we're deleting it. And if any error occurred, it will be listed here. So the error can be like the bucket contains some items, or it has an IAM policy that it cannot be deleted programmatically. So that are the error. Next we have our lambda manager.py file. So similarly we are importing Boto3 and its client error module. Along with that we are importing zip file, OS, time and JSON. So one thing different about this file is we are having two Boto3 client. One is for Lambda, another one is for IAM. The reason we are having IAM here is Lambda function needs an IAM basic execution role for its functioning. So before creating the function, we need to do two tasks. Firstly, we'll create a deployment package. So Lambda function have the code in a zip file, and to create the zip file, we have this function. So using the zip file module, we'll create the deployment package. It will use the lambda function.py file. So we have this file here. So it is a basic lambda function. It will just give hello from Pravesh, your AWS community builder. So after it is successful, it will return the zip file. After that, we will get or create the role based on the instance. So firstly, we'll assume a role policy with a single security token service. And after that, we'll try to get the role and we'll provide the role name as lambda basic execution role. So if any role named after this exists in your AWS account, it will just return the role ARN. And if you don't have this role, which will give you this error, no such entity exception, we'll try to create the role using this IAM client. So we'll provide the name as lambda basic execution role, and using this IAM this assume policy, we'll just dump it inside a JSON. And after that, we'll attach this client, this role with a policy, which will be this AWS basic execution role. So once that is done, we'll wait for IAM for propagation. We'll give it 10 seconds, and after that, our role is created, and we'll just give the role ARN here. After we have the role ARN and the deployment package, we are good to go to create the function. So we'll create this hello from lambda function here. So we are firstly getting the zip file and the role ARN using these two functions above, and we'll open the zip file in read format and save it inside a variable named 𝗵𝗏𝗍𝗏. And using the lambda client create function and providing this parameter, which is function name, which is inside the parameter, the code will be the 𝗵𝗏𝗍𝗏. The runtime is Python 3.9, I guess. So yeah, so it's 3.9. The role ARN will be providing from the function. Same goes with the handler. It is provided here, lambda function.lambda handler. The timeout will be 15 seconds and the memory size will be 128 MB. So if everything goes fine, our lambda function will be created and the function ARN will be returned as response. And if anything occurs, the error will be printed in the console. After that, we have list lambda function. So it will use lambda client.list function, and it will return us an array of functions. So inside the array of function, we'll just get the name, runtime, and the ARN of the function. And if any error occurred, we will print it inside this message in our console. And at last, we have our delete lambda function. We'll use lambda client.delete function, provide our function name, and it will delete the function successfully. And if any error occur in the deletion, it will be printed in the console. Okay, so that's with the code explanation. So now the most important part is, don't just copy this code. I want you to create a new directory, and inside that, create the EC2 manager.py file line by line in your own workspace. Understand how this 𝗪𝗏𝗃 works, how Boto3 works, and how Boto3 clients are created, how the API calls are structured and handled. Then move to S3 manager and Lambda manager. And if you ever get stuck, go to the repo, take a hint, but type it yourself. This will build muscle memory for code and give you confidence, which is very crucial in this AI-assisted development. And even though tools can generate this code for you, but knowing how to write it yourself gives you the real power. So enough with the theory, let's jump into the practical demonstration. So firstly, we'll create a virtual cloud, virtual environment basically, using Python 3, Python M, VNV. We'll activate it. So all the requirements are inside this requirement.txt file. It has Boto3 and Boto code. We'll use pip3 install. Okay. So before doing that, let me show you this main.py file. The main file is the heart of the program. So here we import all the manager class of our services, which is EC2, S3, Lambda, along with have argument parser. So using this argument pass, it basically route the command to correct function. So here you can see that if it is create in the EC2 function, it will use the create function. If it is list, it use a list instance, and similarly goes with S3 and Lambda. So now let's do that in practice. We'll use Python 3 main.py. We'll first start with EC2 instance, EC2 and create. So we have this low EC2 instance, and an EC2 instance is created with this instance ID. So to cross check it, let's use this list command, main.py EC2 list. So here we can see that our EC2 instance with this instance ID is running. We have this public IP of this instance. So if you want to delete or terminate this instance, we'll use EC2, so Python main.py, let's terminate, and here we need just to provide this instance ID. Okay, so it is terminated successfully. If we run this list command again, you'll see the state is running here, but it will be terminated in this command now. So you can see that it's shutting down, and after some time it will be terminated. Okay, so after that, let's move to S3. So Python main.py S3 and create. We'll provide a bucket name. Let's use this only, Pravesh1234, because it would be a unique name. I hope that no one has created a bucket name with this name. So the bucket is created successfully. Let's list it. main.py S3 list. So here we have our bucket listed here, and let's try to delete this bucket. main.py S3 delete, and here we need to provide a bucket name. So the bucket is deleted successfully, and in case you get an error, the error will be printed here. So let's try out with Lambda. main.py Lambda create. First you need to give the name of your function. Let's use Pravesh function, and then we need to define the function file. So here we have our lambda function.py file. We are in the same directory, so let's just run lambda function.py file. So the deployment package is built successfully. We're getting the IAM role, and the lambda function Pravesh function is created successfully. Now let's list this function, lambda list. I think that's all. So here we have a function. The runtime is Python 3.9. This is the function ARM. But before deleting that, let's verify it in our console also. So, and this here we have a lambda. Here is our Pravesh function. So first let's see the code, if it is the correct one or not. Here is our code. It is the same one. Hello from Pravesh, AWS community builder. Let's test it. Create a test series. Okay. Save it. Test. Save. So let's just test it. So in the output you can see that we have the status code, and our lambda function is built successfully, and it ran as expected. So now let's try to delete this lambda function using our Python CLI. main.py lambda delete. Our function name is Pravesh function. So lambda deleted the function successfully, and this concludes the project. So this project is a great foundation. You can extend it further by integrating more AWS services like RDS, DynamoDB. You can improve the error handling and the logging For example, in the S3 delete function particularly, you can add a logic that if the S3 bucket contain objects, you should delete it in a recursive manner so that the objects are deleted first and then the bucket should be deleted. And you can wrap the CLI of Python in a Python package and distribute it among your friends. And you can even integrate this Python CLI in your CI/CD workflow. So if you want to try out this project yourself, I have hosted it on my GitHub repository as I've shown you earlier. So a link of that would be in the description box. I will be writing a detailed blog post about this project on my blog.praveshsudha.com. So make sure to check it out. Also, you can find me on GitHub, LinkedIn, Twitter. Link will be in the description box. And if you enjoyed this video, make sure to give it a big thumbs up, share it among your network, and subscribe to my YouTube channel for more AWS and DevOps related content. So this is Pravesh signing off. Keep automating, keep building.